Hi everyone, welcome to G World of Academic Physics. Today we will discuss some of the illustrations on electric field that can help the student to improve the ability of their thinking. Let me discuss the questions 1. How the questions has framed. This is a non-conducting ring having charge Q is uniformly distributed. This is a non-conducting ring having charge is Q and radius of the ring is R and charge Q is uniformly distributed. What happened? A small section of the ring has removed and this small section is length x. A very small section has removed and this length is x. The questions as framed, find the expression of electric field at the center of the ring when this small section is removed. Find the magnitude of electric field at the center of the ring when this small section is removed. After removing the small sections, one can predict the scenario will be like this. This is my ring. This is electric field. We need to find the expression of electric field at point O after the removing a small section of length x. This is the scenario and the questions has framed on this. When this kind of questions has framed, a student must have to think what? This complete ring in the real sense is a combination of two things. One is this remaining section ring plus a small sections, or you can say a small arc of length x which has removed. Yes, the small section which has removed. And I know the expression of electric field at the center of the ring is 0. Electric field at center is 0. And this electric field at the center of complete ring, this is the electric field at the center, I can say complete ring is 0. And this complete ring is a combination of these two scenarios, that is electric field due to remaining plus electric field due to arc equals to, I can say 0. If this is the scenario, I can say electric field due to remaining is nothing but negative of electric field due to an arc. Yes. And which point we need to find? Exactly at the center point we need to find. And what the question is framed? The question has framed, find the expression of electric field at center O and that magnitude of the electric field it is asking. So when the questions has framed magnitude of electric field, so we must find electric field due to remaining magnitude is equals to electric field due to an arc. It's simply magnitude. When you are talking about the magnitude, we are not looking for this negative signs, we are not looking. And I know from my previous lectures, if you observe, what is the expression of electric field due to an arc? The expression of arc having length x and it subtended an angle theta. If it is subtended an arc, if it is subtended an angle theta, what is the expression of electric field? In our previous lectures, these things have already derived. And what is the expression? The expression is 2k lambda by r sine theta by 2. This is my radius r. 2k lambda by r sine theta by 2. If I will substitute this value of k, this is 2. K value is 1 by 4 pi epsilon naught r lambda sine theta by 2. And very carefully a student has to be observed what is the value of lambda. If you observe carefully, we know charge equals to lambda into length x. The total charge is what? Q equals to lambda into x. What is lambda? Charge per unit length. So one can substitute, this is 2 4 pi epsilon naught r, and lambda is charge per unit length. Unit length, when you are talking about this thing, this is the complete ring length, and the complete ring length is 2 pi r, and this is sine theta by 2. I hope the scenario is clear to everyone. So what is the expression is coming? Q upon 4 pi square epsilon naught r square. This is sine theta by 2. I hope this scenario is clear to everyone. And I already said theta can be written as what? We know this is the expression theta. Theta equals to angle equals to arc upon radius. So in place of theta, I can substitute as x by r. This is q upon 4 pi square epsilon naught r square, and this is sine x upon 2r. I hope this scenario is clear to all. Yes, these questions. Let me do here. If I'll say theta is very small, if I'll say theta is small, yeah, assumptions I'll consider, because a small, very small sections has been removed here, making an angle theta. So if I'll say theta is very small, can I say sine theta is equivalent to theta? Yes. In this case, this is my q. Yes. In this case, then sine x by 2r can be written as x by 2r. So what is the result that I will reach? The result I will reach, this is q upon 4 pi square epsilon naught r square into x by 2r. And what is the expression? This is q x upon 8 pi square epsilon naught r cube. This is the desired result, the desired answer that I will reach. Look at the question one more time for the student perspective. A complete non-conducting ring of charge q uniformly distributed over this ring, and this radius of the ring is r. A small angle theta subtended, a small length x has removed from this ring or cut from this ring. Now the ring will look like this. The questions as framed, find the magnitude of electric field at the center of the ring. If this kind of questions as framed, a student has to be think this complete ring is combination of the two rings, and we know the electric field for a complete ring at the center is 0. For a complete ring, electric field at the center is 0, and this electric field is combination of this ring and this ring, this remaining ring and the arc shaped ring, and we know that the whole thing is 0, so we concluded the remaining ring is nothing but electric field due to an arc, and we know the expression of electric field due to an arc exactly at the center O. This is one of my video, I have solved this question. The expression is 2k lambda by r sine theta by 2. 2k, k value I will substitute 1 by 4 pi epsilon naught r, and lambda I substitute, lambda is charge per unit length, that is q upon 2 pi r, and sine theta by 2. If I will consider theta is very small, then sine theta equivalent to theta, and I concluded this result are like this. I hope this questions is clear to my student. Let me do one more illustrations so student can easily predict what the second questions. Yes, do the second questions. How the questions as framed. This is an infinite sheet. This is an infinite sheet having surface charge density is sigma. A surface charge density has sigma. A small section, you can say one sections of radius r has removed from this infinite sheet exactly at a distance of root 3 r. A charge q, negative charge, has placed. Question is asking at what speed it will reach at this point. This is A, suppose this point is B. At what speed it will reach at point B if the negative charge will be here having mass is m. The negative charge having mass is m. It means a infinite sheet has given having surface charge density is sigma. and a small sections has removed. You can say a disk sections has been removed from this infinite sheet. Now the scenario will be like this. The scenario will be like this. A section has removed and one negative charge exactly at root 3 r distance, one negative charge of mass m, it will be here. This charge at what speed it will come to this, at what speed it will reach at the point B. When it will cross this point B, at what is its speed at point B. Like this the question says framed, and the radius of the disk is suppose r. If you will observe this question is combination of two things. One is the sheet, it means you can say this is infinite sheet minus a small disk has been removed, then the scenario will become like this. The cavity will be formed like this. And I know the expression of electric field at certain point due to infinite sheet, it is sigma by 2 epsilon naught. And I know the expression of electric field, suppose I will say this distance is x, which I will assume as root 3 r. The distance is what? Suppose at distance x and radius r, what is the expression of electric field at point P? Point A, let the point A, because I have considered this point A. The expression of electric field is sigma by 2 epsilon naught 1 minus cos theta, or cos theta can be written as sigma by 2 epsilon naught 1 minus cos theta can be written as what? X by x square plus r square root over. In our previous lecture, these questions are derived. I will suggest to my student, please go to the previous lecture, have a look on this. So I know the expression of electric field due to an infinite sheet, infinite non-conducting sheet, that is sigma by 2 epsilon naught. I know the expressions of electric field due to a non-conducting disk, the expression is sigma by 2 epsilon naught 1 minus x by x square plus r square root over. And after removing from this to this, I will get these things. So the net electric field is nothing but electric field due to infinite sheet minus electric field due to this disk. So what is the expression is coming? Sigma by 2 epsilon naught minus sigma by 2 epsilon naught 1 minus x upon x square plus r square root over. I will get the desired result, that sigma by 2 epsilon naught, this one has cancelled, and I will get the desired result, that sigma by 2 epsilon naught x upon x square plus r square root over. This is the expression of the electric field. This expression of electric, due to this expression of electric field, what will happen? This charge has coming down. This charge will be come down. Sigma by 2 epsilon naught x upon x square plus r square root over. This is my electric field. I know F can be written as Q charge into E. This is the amount of charge, this is the negative charge, and this is the electric field. And I know that F equals to what? Minus Q, and what is the value of sigma electric field? Electric field at this point, what is the expression of electric field at this point? This is the expression, that is sigma by 2 epsilon naught x upon x square plus r square root over. Yes. And if you observe very carefully these sections, with increase of the distance, the field will be changed, because it depends on x. It depends on x, one can say. So I have to do the integration techniques. F can be written as ma equals to what? Minus q, that is sigma x upon 2 epsilon naught root over of x square plus r square. And this can be written as m, a can be written as v dv by dx minus q sigma x upon 2 epsilon naught root over of what? X square plus r square. So let me rearrange these things. What is the expressions? I will get it little carefully. I have to do it here. Let me do it here for the student perspectives. So this is m v dv equals to, one can write like this, minus q by 2 epsilon naught, minus q by 2 epsilon naught sigma, this is x upon x square plus r square root over, and dx is here. This is my result. I can be in my mind doing the integrations here, doing the integrations will be here. Initially it was at rest, now it come down. At this point, what is its velocity? So initially it was rest, final velocity is v. Initially it will be at distance of root 3 r, because it is at what distance it will be, root 3 r distance. After that it comes to 0, because it reach at this point. Initially it is distance here like this. And I know x dx integration or v dv integration, that is v square by 2 q by 2 epsilon naught sigma. This is very important. I must have to substitute something. So I will substitute here x square plus r square, I will say this is t square. So 2x dx, I will say 2t dt. So this 2 has cancelled. So in place of x dx, I substitute this is t dt. This is important. And x square r square, I will say t square. So t square root over, this is nothing but t. And I must think about this limit part. When x equals to root 3 r, when x equals to root 3 r, I will substitute this is 3 r square plus r square equals to t square. So t equals to what? 2r. When x tends to root 3 r, t equals to 2r. When x tends to 0, if I substitute x tends to 0, so what is the expression? T equals to r. So it is very clear, the limit should be 2r and this limit should be r. When x is root 3r, when the value of x is root 3r, the value is 2r, t value is 2r. When it will be 0, the value of t is r. Doing the simple mathematics, this is minus q by 2 epsilon naught sigma. And what is the result I am getting? T has cancelled. This t has cancelled. The expression is coming dt. This is dt. And the expression integration of dt, this is 2r. This is your r. Yes. So mv square by 2 equals to minus q by 2 epsilon naught sigma. This is 2r, integration of t is t. This is now r. This is what? 2r. So this is what? Minus q. This is simple mathematics I am doing. This is sigma. And this is, you can say, r minus 2r. Yes. So expression is coming minus q by 2 epsilon naught sigma. This is minus r. 1 minus mv square by 2 here. I want what? What is the velocity is asking. So velocity equals to what? This is positive. So q upon 2 epsilon naught. This 2 also cancel. No need to write 2 here. Q by epsilon naught sigma r upon m whole root over. This is the expression of velocity at the point B. This is the expression of velocity at the point B. I hope this picture is clear to everyone. How the questions has framed. One more time for the student perspective, I want to discuss these things. The questions has framed. A disk, a infinite non-conducting sheet is here. A small section of the disk has removed. The question is asking at the point A, a negative charge Q having mass m is situated. Now it released. What will happen? It comes down and reach at point B. When this charge passing through this point B, what is the its velocity exactly at this instant? This is, you can say, this situation is combination of this situation and this situation. If I will, from infinite sheet, I will remove one disk sections, I will get this desired result. I know the expression of electric field at point A, that is sigma by 2 epsilon naught, and I know the expression of electric field at distance x at point A. This is the expression of the electric field. In our previous lecture, this is already had derived. So net electric field, I will get it sigma by 2 epsilon naught x by x square plus r square. This is the net electric field, you can say. And due to net electric field, what will happen? And if you write with a sign conventions, this is obvious things that this is, if you want in a vector form, this is go upward and this one also go upward. So net electric field also in upward directions, like this. The net electric field will be upward direction, because due to a point the field is goes like this, due to a point this field is goes like this. So net electric field is upward directions. And I introduce, this is negative charge, definitely if the field is upward, the force will definitely act in downward directions. Using this concept, I reach this conclusion that mvdv equals to like this. Doing the simple integrations and solving this question, I will find the expression of velocity, and this is the desired answer. Let me do one more illustrations for the student perspective that can help the student to improve their ability of thinking. Suppose the questions as framed like this. This is a, you can say this is a infinite rod, and exactly the rod is bent in the form of U shape, and this section also it goes to infinite. Exactly at point O, the questions as framed, find the expression of electric field. This is a positive rod. Charges have been uniformly distributed, having line charge is lambda, and the line charge is lambda. The question is exactly framed. This end goes to infinity, this end goes to infinity. The question says framed, find the expression of electric field at the point O. If solving this question, a student must has to be think about what is the expression of electric field due to one end goes to infinite rod. If I will break this segment, I can break this segment as this is segment 1, here to here this is one segment 1, here to here this is another segment 2, and here to here this is another segment 3. A student usually have to think like this: segment 1, segment 2, segment 3. The total electric field at center O is nothing but the electric field due to segment 1 plus electric field due to segment 2 and plus electric field due to segment 3. These are the way a student has to break it. If you observe very carefully, this is one end goes to infinite rod. At O point, I need the expression of electric field, and this is very obvious. At O point, the expression of the electric field at this point has two components. One component is here and another component will be two components of electric field. One component will be like this, another component will be like this. If the electric field goes like this, one component is like this, another component will be like this. So the expression is k lambda by this distance. Suppose this distance is r, k lambda by r. In this section, this is k lambda by r. Similar fashion, if I will proceed like this, the expression of electric field, it will be go like this, and it has two components. One component is like this, another component will be like this, and the one component goes like this, another component will be go like this. No, this is little wrong. Little carefully has to be think about it. This is positive. It is positive means it will definitely go like this. Sorry, it will go like this. So one component is here and another component will be here. This is 1 k lambda by r. This component also k lambda by r. One more time, this is not visually properly correct. So I will do one way like this. This is segment 1. Due to segment 1, exactly point P, the component will be like this. One component will be like this, another component will be like this. Similar fashion, if I look at this segment 3, the segment 3 will be here. So definitely segment 3, so definitely due to segment 3, one component will be here, another component will be like this. Because it will go like this, so one component here, another component is here. Similarly, it goes like this, one component is here, another component will be here. So what is the expressions here? This is k lambda by r, here k lambda by r, and here also k lambda by r, another component here also, this is k lambda by r. This is very important things a student has to be in the mind. Very carefully has to be predict like this. Here it goes like this, two components like this. Here it goes like this, two components like this. There will be another sections will be like this, and due to this is also a positive section. So what will happen? Due to positive section, it will be go like this. And I already solved my lectures that what is the expression of these things, that is 2k lambda by r. If you observe carefully, k lambda by r downward, 2k lambda by r is upward. So this is 2k lambda by r, this is 2k lambda by r, the net electric field will be 0. One more time I want to repeat to visualize for my student. This is one section. Due to this one section, the electric field will be like this and like this. Due to this sections, the electric field will be like this and like this. These two components have cancelled each other. There will be only one component, that is k lambda by r due to this, and k lambda by r due to this. So total is 2k lambda by r. Now look at these sections. Look at these sections. These sections, the electric field expression at this point is 2k lambda by r, and below it is what? Due to this 1 and 3 segment, k lambda by r plus k lambda by r, 2k lambda by r. So the net electric field at point O will be 0 because upward and downward has cancelled each other. I hope those questions are clear. If these questions are clear, do one more illustration so that student can be easily visualize these things. This is the scenario. This kind of questions is very common and it helps the student to think about it. This is the point. At O point, find the expression. This rod goes to infinity. This rod goes to infinity. All are positive rods, I will say. These are all positive rods. So if you observe very carefully these sections, this infinite rod, this is segment 1, this is segment 2, this is segment 3. Here to here, this is segment 3, here to here segment 2, and here to here, all these are segment 1. Due to one end goes to infinite rod, what is the expression of electric field? If I will connect somehow like this is one component will be go like this, there will be another component will go like this. Because the electric field will be go like this, so it has two components like this, like this. Similar fashion, if I will think about it, due to this rod at this point, one component will go like this, another component will be go like this. And every component, if I will consider this is radius r, so this is radius of the small arc if I will consider. So expression here it is k lambda by r, here k lambda by r, here k lambda by r, here k lambda by r. So due to segment 1 and segment 3, the net field at this point is 0. Segment 1 and segment 3, the net electric field at this point is 0. Now we will think about this arc. I will think about this arc, and we all know in our previous lectures these things have already discussed. I will suggest my student to please go and check this video. Electric field due to one arc, quarter arc. Electric field due to a quarter arc, the expression of electric field will be like this. And what is the general expression? I said 2k lambda by r sine theta by 2, and 2k lambda by r sine, this is 90 degree. So sine 90 by 2, you can say sine 45 degree. So this is sine 45 is what? 2k lambda by r, sine 45 is 1 by root 2. So expression is coming, this is multiply 1 root 2 here, 1 root 2 here. I will get the expression is root 2 k lambda by r. So due to a quarter arc, what is the expression? The expression is root 2 k lambda by r. And this is in which direction? This is root 2 k lambda by r. Already due to 1 and 3, all the components have cancelled. Only due to this segment 2, the expression of electric field is 2k lambda by r. So the net electric field, what is the expression of net electric field? The net electric field expression is root 2 k lambda by r at this point O. Net electric field at point O. I just want to recall one more time. This is three things. One segment 1, segment 2, segment 3. Segment 1, an infinite rod, one end goes to infinite rod having two components. This is the two components. This is segment 3, two components. This is one component, this is one component. These two components have been cancelled each other. Every components have cancelled each other. Now think about the segment 2, and I know the general expressions 2k lambda by r sine theta by 2, and this is a quarter ring, so angle is 90 degree. So substitute here the 45 degree will get it root 2 k lambda by r, and this root 2 k lambda by r exactly goes like this. So this is the expression of electric field at the center O if this kind of segment questions are framed. I hope this scenario has clear to everyone. Thank you everyone. Thank you for your watching.